guys, how are you? So, in today's session, we are going to talk about the applying AR, that means the association rule learning to the grocery store for market basket analysis. So, basically, in today's session, we are going to talk about like how the association rule learning will help in the market basket analysis. Like if you have a grocery store and you have to manage your groceries, like you have to keep your butter, milk, bread and soap, spray and something like that in a such a way so that if customer came, then he can buy as much as he can. So the association rule learning will help in this grocery store that many things will get by a single customer, and you have to place the things like that. So let's start with our today's session. And market basket analysis is one of the key techniques used by large retailers to uncover association between items. So basically it is saying that uncovers the relations, or you can say the association between the items. Like when a customer came, and when he came and buy butter, then there's like probability that he can also buy bread also. So this association rule learning will helps the large retailers to uncover relations like that. You can keep the butter and bread at same place so that if person buy butter, then he can also buy the bread and some other products. Like if he buy milk, then he can also buy some chocolates or some other combinations like that. So it works by looking for combinations of items that occur together frequently in the transactions. To put it another way, it allows retailers to identify relationships between the items that people buy. So basically, it helps the retailers to identify the relationship between the items that the people buy. Association rules are widely used to analyze retail basket or transaction data and are intended to identify strong rules discovered in transaction data using measures of interest interestingness based on the concept of strong rules. So based on the concept of strong rules, they were trying to discover some measures of interestingness, or you can say like relationship between the items. And so now how can we determine the strength of the association or the relationship between the two items, or two or more items? To answer this question, we need to consider three metrics. The first factor came is support. This metric is indicative of how frequently the products appear in the dataset, like how how many times this product is get bought. For example, if we have 10 transactions and pens appears in 7 transactions, then the support is 7 out of 10, which is 70%. High support percentages are preferable as they indicate that the association is likely to apply to large number of future transactions. Like support X turns to Y, where support X union Y. And we try to figure out that how many times the X is buyed, or you can say like how many times the Y is buyed if we buy X. So confidence, this matrix is indicates the probability that transaction that contain a certain product X will also contain product Y. X belongs to Y. So basically, like here, as you can see that if you want to see the support of two products, you just combine the support of single product and the other product and combine their support. So this is different, and this confidence is different. Like if you buy one product, then how many there is chance like you buy second product. So confidence of buying Y when you buy X is support of X and Y divided by support of X. The issue with this metric is that the confidence might be inflated with if both X and Y are popular or frequently purchased products. So we need to find a way to control the popularity of Y, and the way is confidence X, and the confidence is X when Y when X is bought, support X, support of XY, support of X. Lift. This matrix is indicative the probability of Y being purchased when X is purchased while controlling the popularity of Y. So by using this lift method, the popularity control of Y is being managed, and this matrix is indicative of the probability of y. So to control the popularity of y, we need to measure the probability of all the products in the rule occurring together and divide it by the product of probabilities of the products as if there was no association between them. So to control the popularity of y, we measure the probability of these products, like in different products. We measure their po- probability of buying the product, and then divide by the product probabilities of the products as if there is no association between them. For example, if milk and cheese occurred together in 2% of transactions, milk in 15% of transaction, and single cheese in 5% of transaction, then the lift is 0.02. 2% divided by 0.15 into 0.05, which is 2.7, and this is the lift. A lift value that is equal to 1 indicates that product x and y are independent of each other. We should look for lift values greater than 1 because these values mean that the item y is likely to be bought. If the item x is bought, the larger the lift, the greater the link between two products. So that's how this lift value is calculated. Like lift of xy equals to support xy divided by support x into support y. So this is the some rules, like rule x and rule y when x is both support and confidence and lift. And this is a simple example where someone buys ABC product and someone buy ACD product, and someone buy BCD product and another person buy ADE product and another person buys BCE products. So this is the support, confidence, and the lift values for the products as given. Like if I talk about the A and D, when A is bought, how much time the D is bought. So support is 2 by 5. There are, you can see that two persons will buy D when A is bought, and confidence is 2 by 3 and lift is 10 by 9. Next is like an example of association rules. Assume there are 100 customers, 10 of them bought milk, 8 of them bought butter, and 6 bought both of them, and bought milk and bought when butters get bought and when milk is bought, and after that butter is bought, support for milk and butter is 0.06, confidence is 0.75, and the lift is 7.5. Note, this example is extremely small. In practice, a rule needs the support of several hundred transactions before it can be considered statistically significant, and datasets often contain thousands or millions of transactions. So this example is based on 100 customer transactions. So in real life, we have like thousands or millions of transactions in our database, and we consider that to make these rules. And and that's all for the theoretical session where we talk about the applying AI to the grocery store for the market basket analysis, and we talk about what is market basket analysis, how we apply the AR association rule learning, and what is how we measure the how we get the relationship between them, which metrics should we use to find the relation. Like we get to know about support, confidence, and the lift, and we consider an example for it, that what is the value of support, confidence, and lift if we consider a small example. And that's all for the theoretical session. Now we move on to the coding session where I'm going to tell you about that how you can apply the association rule learning to the market basket.